Hey guys, go ahead and get out your note sheet for 11.1, 11.2. So with dividing polynomials, you're going to be looking to put things in simplest form, which means when you have a rational expression, you're going to simplify the numerator and denominator until they have no factors in common other than 1. So rational expression just means fraction, so you're looking to basically simplify numerator and denominator until there's nothing left that you can actually simplify. Okay, so for 11.1, we're going to look at dividing polynomials by monomials. And so the rule for this is to divide or reduce the number bases and to subtract the exponents for like variable bases. So this first example that we have is actually like chapter 7, since it's a monomial divided by another monomial. The laws of exponents and what we're talking about right now states to look at your numerical bases that are not the same, so 18 and 60, divide or reduce that. So we can't divide it and get a whole number, but we can reduce it. And I know that 6 goes into 18 and 60, so we could reduce that to 3/10. And then with your like variable bases, the laws of exponents say to actually subtract. So we would do 2 minus 3, which is -1. But if you had x to the -1, that really means that there's 1 left over on the bottom. Or if you envision x squared on top and x cubed on the bottom, you can get rid of x squared on the top, but then you take away 2 from the bottom, which is why we have x on the bottom left over. This second example is showing a binomial divided by a monomial. So what you're going to do for here is you're going to divide each term or part of the numerator by this denominator 3x. So what we want to think about is actually two different divisions here. It's the first term divided by 3x and the second term divided by 3x. If you don't need to separate these and split them apart, you don't have to. I'm going to show it split apart so you can think of it as two different divisions. If you can just divide it by 3x each individual part and get your final answer, that's fine as well. So if we separate it, we're doing 12 divided by 3, which is 4. That's regular division. And then when you have these like exponents, we would have x squared divided by x, which is really going to subtract. That's going to be 4x. And then you have y on top and no y on the bottom, so y would remain on top. So basically you no longer have a fraction, this just becomes 4xy. Minus 3x divided by 3x, well, it's the same thing over itself, which just makes 1, and that would be simplifying. There's nothing left to do here. Third example is actually a trinomial divided by a monomial. So again, this really means all three parts of the numerator divided by that denominator 3rs. So if you choose to separate it, you would end up with 3 different parts, so like you see here. Or if you want, you can just really kind of circle off each section and divide individually like that. So 6 divided by 3 becomes 2. And then if you have r squared over r to the first, that's going to be r. S squared over s becomes s to the first. Your second group, you've got 3 divided by 3, which is 1. R over r would go away, that cancels, and then s squared minus s to the first is s. And your last group, 9 divided by 3, is 3, and there is a minus sign, so we're going to kind of bring that down. R squared over r would be r, and then s over s cancels, so that would be your final answer since there's nothing left to simplify because you don't have any like terms here. Okay, fourth one, again, it's another trinomial divided by this monomial denominator, so you can choose to, if you like, separate the entire thing into 3 different divisions, or you can just look at each part and do your division. So we've got 3 divided by 3, which would make 1. A squared over a is a. B over b cancels here, so no more b. Your second part is 6 over 3, which is 2. A cubed over a to the first makes a squared, since we're subtracting. B squared over b to the first is b. And your last part, 18 over 3, is 6. AB, or A over A, is gone, and B over B is gone, so that's just a 6. Again, this final expression here can't be simplified further, so you can just leave it as is. Here's 4 more practice problems. Go ahead and press pause and try these 4 on your own, and then press play and check your answers. So number 5, you should have just been able to reduce 25/15 to get 5/3, and then x squared, y squared. Number 6, 14 over 4 reduces to 7/2 with x squared, y squared on top, plus 4y for the second part. Number 7, you end up with 5xy plus 4y minus 1. And then number 8, you end up with 5x minus 15y plus 20. So that's it for 11.1 with dividing by a monomial, and we're going to take a look at what you do when you divide by a binomial next. Okay, so what you need to think about when you're dividing by a binomial is because a binomial is technically, pieced together as a binomial. You're going to factor the numerator and or denominator completely, and then in order to simplify these, you can only get rid of or simplify if you have exactly the same binomial on top of the fraction and on bottom of the fraction. They can go away. If you don't have those, there's nothing you can actually simplify. You're not allowed to take pieces of a binomial and reduce it with anything else. The only way to simplify here is the entire binomial has to be the same on top and bottom to get rid of it. So here's a look at your first example, and so again, your rules really are to factor completely the numerator and denominator and then simplify. If you have the same binomials, just get rid of them from the top and bottom. So my goal here is to take this numerator and to actually factor it. So the nice thing here is that a is 1, so I really just need the factors of c, which is 4, that are going to give me b, which is -5. And so I know my factors of 4 are 1 and 4 and 2 and 2, and to get -5 I need my 1 and 4. So that numerator, because again a is 1, we don't have to do box method or anything special. The numerator factors into x minus 1 and x minus 4. The denominator is x minus 1, and I know you don't have parentheses around this, but that is a binomial, so I would always suggest putting parentheses around those so you know it has to stay together. And then the only way you can simplify is if you have those same two binomials on top and bottom, they can cancel, and then what you're left with is x minus 4. And that would be a binomial, and that's your final answer. So dividing here, polynomials by binomials, is factoring and then getting rid of common factors on top and bottom and writing what you're left over with. Second example here, same concept, so we're going to factor the numerator completely, and if you look carefully at the numerator, there's actually a GCF of 2. So if I take out a 2, I would be left with x squared minus 3x minus 4 all over x minus 4. And again, I'm going to put x minus 4 in parentheses because the only way to simplify that is if I have another x minus 4. So now again, I've created this easier problem because a is 1 in this new trinomial on top. So when I go to factor that, I just need the factors of AC, which is -4, that are going to give me b here, which is -3. And I should know that those factors are going to be -4 and 1 to give me -3. So I'm going to go ahead and factor the top, x minus 4 and x plus 1. That common, that 2 that was your GCF, remember we have to keep that so it just stays out front. And then if I'm going to simplify this anymore, I see that I have that same two binomials on top and bottom, so I can get rid of them, and then my leftover answer would end up being 2 times x plus 1. You don't have to redistribute, you can leave it like that, but that's all your leftovers, and then you're good. Okay, third one is really a binomial divided by a binomial, but if you look really carefully at this numerator, it is a binomial where there's no middle term, so that really means in the middle there was a plus 0x. So, you know, if you're ever needing to factor a binomial, you need to look at, is there a GCF? No. And then look at the first and last term. This looks like these are both perfect square numbers, and you have a minus, so that's a difference of squares. So when you factor a difference of squares, it's taking the square root of 4x squared. That's going to be 2x times 2x. The square root of 9 is 3 and 3. And then you need opposite signs, which makes that middle cancel out and make a 0. Denominator here, again, I'm going to put in parentheses so I know I can only cancel it if you have the exact same thing, and I see those same common factors, 2x minus 3 on top and bottom. So my final answer on what's left over here should end up being 2x plus 3. Okay, and then example 4. So again, the numerator looks like it needs to be factored. It's a trinomial. There's no GCF, so I'm going to do a times c, which is -30. And look for my factors of -30 that are going to give me b, which is -1. And I can list them all, but I kind of know that 5 and -6 are going to give me -1. And this one is where a is greater than 1, so you would have to either use guess and check or box method or factor by grouping. So you can go ahead and pause and get your factors from there. Okay, so I just finished with box method, and I ended up getting 3x plus 1 and then 5x minus 2 as my factors. And my denominator was 5x minus 2, and so I could see that those will cancel, and my leftover answer would end up being 3x plus 1. So I'm not sure if any of you guys have realized as we've gone through these last examples that Basically, if you have a trinomial divided by a binomial, one of your factors of that trinomial will always be what the binomial was. That's the only way you can really simplify this, is if we were able to factor the numerator to get a 5x minus 2. So there kind of is a mini shortcut of doing these, and the mini shortcut's the whole understanding of FOIL. If you already know that when you go to factor this, that this is one of your factors, then you can start thinking of this as 5x times what other binomial is going to create 15x squared. And that's because it's your first two terms multiplied to create 15x squared. And since you know 5x times 3x is 15x squared, you should automatically know that the next binomial, or your part of your answer, is going to be 3x. Then you can look at the negative 2 and look at the top, and you need to multiply to create negative 2. And the only way to multiply negative 2 by something to get negative 2 is going to be positive 1. And that's technically going to end up being your answer for every kind of problem like this. So it's kind of a shortcut because you know 5x minus 2 should be one of your factors. When in doubt, you could still just factor the numerator, but because you're simplifying, that means you're trying to get rid of 5x minus 2, so it has to be one of the factors, so you're just finding the extra missing factor. So go ahead and press pause and try these last 4, and then press play when you want to check these. And again, it's look for a GCF, factor, and then find the missing binomial, and or you can go with that little shortcut I just showed you guys and see if you're getting them right like that as well. All right, so number 5 should end up being x plus 3, and your factors were 4x minus 1 times x plus 3. Number 6 was your factors were x plus 7 and x minus 9, and so your leftover and final answer should just be x minus 9. And I'm going to show you 7 and 8 again with these little shortcuts. So for number 7, since the numerator has to have a 2x minus 3 factor, and in order for it to simplify and cancel with the 2x minus 3 on the bottom, then you're just kind of understanding FOIL. If this is 2x times what's going to make 6x squared, that has to be a 3x. And then if you know it's negative 3 and a blank, so negative 3 times blank has to be positive 6. Negative 3 times negative 2 is where you get positive 6. So your leftover factor here is a 3x minus 2, and that would be your final answer. And then the last one as well, so 2x plus y is on the bottom. That means it should be one of the factors on top. That's the only way you're going to be able to simplify and make it cancel on bottom. And so we're doing that concept again of 2x times what here is going to give me 10x squared. That has to be a 5x. And then y times what here is going to give me negative 4y squared, and that should be a negative 4y. And so those cancel, and your answer here ends up being 5x minus 4y. Like I said, when in doubt, you can just factor, but the idea really is if you're simplifying these, the only way to do it is by getting rid of the whole denominator binomial, which means it has to be a factor of the top in order for you to get rid of it. So that's it. I will see you all soon.